Example 9.13, use table 9.1 to predict the length of A, the nitrogen-nitrogen bond in hydrazine. And here are the possibilities from table 9.1. So we need to write the Lewis dot structure for hydrazine to figure out whether the nitrogen-nitrogen bond is a single bond, a double bond, or a triple bond, right? So if you look at this, hydrazine has 2 times 5 plus 4 times 1 is 14 electrons. And when you draw its Lewis dot structure, when you've gone this far, you've used 2, 4, 6, 8, 10 electrons. So then there's 2 more pairs, and those pairs finish up the octet on the nitrogens. So this suggests a single bond. And 145 picometers is what the table predicts for a nitrogen-nitrogen single bond. If it had been a double bond that came out of the Lewis dot structure, we would suggest 123, or a triple bond would be 110. Questions on that? Okay, so you've got to be able to do the Lewis dot structures. What about part B, the bond in BrCl? Okay, BrCl is a heteronuclear diatomic here, and what we could say essentially is that the bond length of BrCl is approximately equal to the radius of Br plus the radius of Cl. Now we know it's probably going to be a little bit smaller than that based on the example I did for you last time, but this is a good guess. So the radius of Br will be half of the distance between the 2 bromines and dibromine. And the radius of Cl will be half of that distance in chlorine molecule. So this is 228 over 2 plus 199 over 2, and that's about equal to 214 picometers. And we'll probably, this gives us a high side guess. It's probably going to be a little bit less than that because it's a polar molecule.